Vou tentar não passar do tempo para respeitar o monte de todo mundo. And first of all, I'd like to excuse myself because I do this in English. I work at a globally distributed team. There are guys who made an awesome job at some of the stuff that I'm showing you today. These guys are watching us online. So first of all, to the guys who are watching, thanks, wish you were here. But let's kick this off, let's get started. So, my name is Diogo. I'm a developer, I'm a software architect and a teacher. And I've come here to tell you a little bit of a love story. What can go wrong, right? Love stories during a developer conference, yeah. But this love story has two main characters. First of them is a language called JavaScript, which I think you already know by now. If you don't, I heard there's this dude at the end of the day today who knows a thing or two, he can answer some questions. The other one, the other big player here, it's a company you probably do not know. It's called Echo Corporation. We own brands such as Massey Ferguson, Valtra, Challenger, Fendt. So our core business is building machines for farmers, for agriculture. And, well, you know, it's a very traditional field. So probably the first thing you're asking yourselves is, man, this guy builds tractors. Why does he care about tech? The answer is, it's not because you're in traditional field that you don't do innovation. Just to give an idea, CVT transmission, all the rage these days about, you know, those shiftless machines, those shiftless vehicles. We've got patents for that dating back to the 70s. Market was just ready for that sort of stuff on 95. Tracking. We do tracking on machines on the field for a long time. One of the latest installments was in 2010 when we started offering that service through mobile apps in which a farmer can go and see where his tractors or harvesters are, how they're behaving, etc. And recently, there's been all this buzz about self-guided vehicles with all this cool stuff that Google did. Of course, it's a different kind of problem, but we've had self-guided vehicles since 2013. And last but not least, there's this echo thing called Fuse. At any moment of the day, right now at this moment, there are literally millions and millions of machines out there in the field working on the field. Those machines, those tractors, those harvesters, those sprayers, they are getting increasingly sophisticated. That means that we are able to collect data from them. They can send data to us. They can do self-diagnosis. They can do lots of cool things these days. And in recognition to that, and to the massive scale of data that we'll be collecting, and to the massive importance that data is going to have on the daily life of farmers, we have created this initiative called Fuse, which is about integrating data of all machines out there in the field. And that's what drove us to being here, talking about the stack that I'm going to show you today. But before I get into that, you know, as any good love story, it's got to be a bit more of a foreplay. So last year, 2014, we started dating with JavaScript. That's not yet a Fuse case. Let's hold that thought. This is a smaller but interesting case. It is something that happened here in South America when we proposed to go and break a big monolith apart. This monolith was kind of a big beast of a system. Formatting when has gone. Oh yeah. So it was composed of about 800,000 lines of code. It took us more than 13 years in the making of this thing. It was composed of 4 modules, and it ran on a node, bloated, scary, and very, very lonely server. This here was pretty much our web presence when speaking with dealers, and we do all our business with dealers. So, strategy for this sort of thing is something that Martin Fowler calls debt strangling. The idea is that you create abstractions around your legacy, you know, and you mask it from your new stuff, and little by little you go on taking pieces out of that. Now, there had been auto tentatives for that. If you remember those numbers, we had 4 modules. That meant it was the original module, 3 times where we tried to update it to make it more modern, and didn't really succeed. So what we really wanted was to have something that would allow us to detach stuff. And what we did in there was we created this set of APIs around this legacy. Those APIs act as a facade, as an abstraction, on top of all the complexity that lies behind that legacy. And in order not to pollute our UI or user experience with any of that legacy, what we did was we created a standalone page that's pure HTML, static HTML, and JavaScript, Angular for this project, so that could be separately deployed. So we went from one server to a number of those, some of those serving API content, some of those just delivering this pure HTML and JavaScript solution. The results were a much improved user experience. Those days of the post back and interfacing with the server all the time were gone. That allowed us to do much better prototyping. One of the biggest concerns about the team was that they were very experienced with this legacy stack, and they were concerned about productivity, and we didn't have any problem with that. And it was a pretty successful project because it set up a standard. Now, all of our projects, all of our web presence with dealers go through that sort of architecture, that sort of design. Another thing that was pretty cool too is that this UI that we created is being ported over to other parts of the globe. They have completely different backends, but they will abstract in the same way, creating APIs, same data contracts, because they were detached from the legacy. So this solution is actually being carried out this year to Europe and next year to the United States. But this is not the real reason why I came here to talk to you guys. The real thing, the real important thing for us is what's taking place this year. It's our real marriage to JavaScript as a language. Remember Fuse. So for Fuse to succeed, for us to succeed the vision that we had in mind when we start talking about Fuse, we need to make things simple. Our end goal was for the farmer to be able to get data on his hands. It had to be that simple. It had to be composable. We want to be able to compose information and services across a number of data sources so that we can deliver fast information and not worry, say, no, this part here you go that way, that other part you go that other way. We don't want to give that kind of experience. Scalable, we're talking about literally millions and millions of signals coming out of those machines arriving to our APIs. It has to scale. And there are peak moments throughout the day, throughout the month. And one of the biggest differentials here, it has to be open. Open in the sense that we will accept data from any machine out there in the field. So you didn't buy from us, you buy from one of the other guys. Well, what can we do? But you can still integrate. So if you got your farm, it's got one Massey Ferguson tractor, one John Deere combine, you want to collect all your data in one single place, we're open to that. You can send that data to our APIs, we'll collect that, we'll deliver your data back. It's also open in the sense that those APIs are public. They will go live 1 month from now, and they will be available for developers to extend upon them. We do not have the intention of holding all the keys. Still, on the open side of things, we are going for a web open standards approach. So everything you're going to see, it's open standards. We don't want to reinvent the wheel. We don't want to do things on our own. For that vision to succeed, we had to pick up a number of weapons of choice. First of them was the use of RESTful APIs. So RESTful APIs come against the big verbosity that you get in SOAP. So this is a perfect example. You know, if you're doing a SOAP request, you would just go and say, hey, yeah, just not to get confused, the following question belongs to namespace coffee. Could you give me coffee? The number of coffee is 1. The question ends here. While you're doing REST, you're going to just go and say, get coffee. So it's very simple. It's very composable. It's very easy to compose things together. It's very expressive. There's not all that verbiage in there. And it's very open. You can easily extend on top of it. We also picked Node and Mongo as we perceived it as a killer combination for the sort of thing that we want to do. So what were the main reasons? Node and Mongo are very simple. They're very scalable. They are very, very expressive. Big corporations such as ours have a tendency to go for those big, big stacks, a bit like this. We didn't want the orc. That's the thing we knew. We don't want the orc. We don't want an orc being our API strategy. We want the hobbit. That's the one that really did the difference against the dragon of complexity. So it was clear for us that we want something very agile, that's something that would allow us to be very fast. That's why we went with that stack. We also made another decision, which was to be as standardized as possible. We went with an open spec called JSON API spec, and I encourage everyone out there who builds APIs to have a look at that specification. It pretty much specifies a way in which you can structure your JSON payloads and which you can structure your REST endpoints, how you do your routing. The good thing about that is that it's very well documented. It was designed with composability in mind, and that allows you to do no byte shedding whatsoever. So instead of creating your own standard, such as in this XKCD comic, you can create your own. Some folks are probably wondering what the heck byte shedding is about. It's also called the triviality law, and byte shedding comes from the way that the guy who came up with this, called Parkinson, actually illustrated his story. He says that sometimes it's easier to get approval from a board of directors on building a $1 billion nuclear plant because it's so complicated, it's so hard to fathom that people will just say, yeah, those guys are experts, they probably know what they're doing, here's the check. So it might be easier to get that sort of money for that sort of complex project than getting the very same board of directors to agree on spending $100 on doing some renovation on the bike shed. Because that's simple. So everyone feels entitled to give their opinion. And guys, this is just $100. We're discussing a trivial matter when we do this sort of thing. So instead of discussing what's the ideal way to structure our payloads, our routes, we went with JSON API spec. I love the fact that it exists, even though I don't agree with 100% with it, and that's exactly the point. So we've been playing around with that for a while now, and that union has started to bear fruit. I've brought two of those here. First of them, our firstborn, and the most important one is this library that's available on GitHub called HarvesterJS. And HarvesterJS is supposed to be simple, composable, scalable, expressive, standardized, and very open. HarvesterJS is a library to help us quickly create JSON compliant APIs with as little code as possible in the driest possible way. So here's an example. We're seeing here that we are going to use Mongo as our backend, and here we're defining two API endpoints. One of them is called artists, the other one's called genres. So here we're saying that artist has two attributes. One of them is called name, which is a string, which is required, whose description is artist name. And it also contains a link to another endpoint called genre. And there you go, genre has just a name. Very simple example, just to illustrate the point. By just doing that, you get full CRUD. So you get, by just writing those lines of code and running them on Node, you're going to get operations to insert, delete, update, and get many ways of getting the data. So cool, right? You get CRUD, full CRUD with just that, but is that all? Nope. For example, I can go and say, yeah, fetch me that artist and get me all that related data, you know. Embed the data that you're going to send me back with the genre. Or if this artist has a reference to some other entity, I can just go and say, yeah, I want it all in one single get. I can do filtering. I can just say, yeah, give me all artists whose names are Metallica. Or I can go and do sparse field sets. I don't want the full set of data. I just want those 3 or 4 different fields. And the coolest, for me, the two coolest things here is cross-domain inclusions, which means our APIs are very distributed too. So they are very self-contained. And one given resource might have a reference to a resource elsewhere. So for example, whenever you're collecting data from a tractor, you can get information about the model of that tractor. Those guys reside in different API domains. But there are links between them, and you can easily just go and say, yeah, give me the API, give me tractor data, give me the tracking points of this tractor, and by the way, bring me together all model information on it. One single call will cause Harvester.js to hop through those domains and collect all data and give it back to you. And last but not least, and I feel real happy by having that reduced presentation and functional reactive presentation before, that ties very nicely into this last item. We also provide, through that library, something called data event streams, meaning that you can just start listening to all changes in one given API endpoint in a reactive manner. So that way, a given client doesn't have to poll us, yeah, something happened. So through that sort of mechanism, we can create dashboards that receive notifications from our servers without having to poll. We also created another library called Elastic Harvester.js, and this is a bunch of helper functions to allow people to extend functionality on those APIs with an Elasticsearch backend. What does that offer? For example, you can do aggregations. So give me data for all model. Give me data, an average engine hour for all tractors out there that are a Massey Ferguson 7800. You can get that sort of aggregation through that and crossing across multiple different API domains. You can play around with composing. I want to get tractor data, I want to get telemetry data from that, and then I want to filter on that. So you can easily interop all your resources in your queries, and you can use a good chunk of the spec from JSON API. So if you want to do sparse field sets and just get a couple of attributes from each of those entities, you can. Wow. So some of the things that we have learned in the road so far. First of them is, I come from a background in which, people were fearful of JavaScript. People were fearful of dynamic languages. People were fearful of this sort of thing and would feel much safer about using those old classic stacks. Of the many things that you can do to reduce that fear and increase your confidence, and one big thing is do automated testing as much as you can stomach. And that automated testing should be specially focused on end-to-end testing. Those APIs are lightweight, so the days of mocking and getting just one tiny detail in your test should be gone for this sort of architecture. You can bring it all up, you can run tests end-to-end, and see that things are really coming through. That saved our hides countless times. DevOps are a big enabler for this sort of thing. So if you're doing microservice development, if you're doing really getting to the API world, good DevOps practices for continuous integration and delivery are a key enabler to actually be able to deliver on that. What we've perceived so far is that that whole bloated cycle about having to create 20 classes so that I can implement the service, with all those rules, with all that composition, with all that inheritance, those days should be gone. This is the future. This is the way in which you can be productive and still have very high quality code. On the implementation side of things, promises were a big thing for us. Using promises in our code helped us simplify things and avoid callback hell. Now, it is not as simple and straightforward as it may seem. This is more on the architectural side. So when you have multiple APIs that are spread apart, you face a hard choice, which is, what do I do about my complex operations that need to touch multiple different domains? Do I make my client go and interface with them all, letting that complexity rest on the client side? Or do I provide some sort of service that orchestrates those guys and delivers, a consistent and simpler message back to the client? And there's no easy answer here. It has to be something that you evaluate case by case. Still on the API design, if you're doing it, you will get yourself scratching your head about, all right, so what are my resources? What are my entities? Where do they begin? Where do they end? And how do they live? So having a good read at domain-driven design, that's a very good starting point, because there you're going to get introduced to the concept of aggregation routes. and that's the sort of thing that helps a lot in driving API design. Still on that, instead of creating, one single big bloated API, consider creating a chunk of those, a bunch of those, and have them linked together. The technology these days allows you to easily create links between different API domains, allowing clients to hop through them, or even providing some sort of service that does that for them. One of them is to index. So if you are really going to an API strategy, consider creating some Elasticsearch index or something similar that will allow people to very easily query against all those guys that are somehow related, even though they sit in different domains. What is it that we have ahead of us? What are the next things that are going to happen? On the BrazilJS side, we will keep on improving on the DSL. Right now, we have an alpha 2.0 version. We still feel that, we felt that the first version was a bit too verbose for our taste. This thing I showed you is 2.0. It's still work in progress. We are hardening it for our next month go live. So I would recommend 1 month to actually consider putting that in production. So lots of improvements are going to take place in there. For example, since we are already describing our RESTful endpoints, you're already seeing the data context in there. One of the things that we'll provide is out-of-the-box Swagger documentation for API. Just describe it through DSL, and we'll auto-generate Swagger through the library. Another thing is, since we kicked off the project, JSON API hit version, a very important milestone. The spec hit version 1.0. We're still not fully compliant with that. We're going to be there a couple of months from now. And on the API, on the echo side of things, especially for APIs, we are right now in the process of hardening our APIs. So we'll go live real soon with a bunch of public APIs that will be made more public and that will be made broader for usage across the next months. This strategy is considered so critical that we are eating our dog food, and we're using that very same concept within our company. We are building our services and interfaces within the company as APIs that are easy to compose and use the same sort of concept that I've showed in here. Last but not least, we are going to a world in which those very complex machines, those very sophisticated machines, will have enough computing power to actually behave like APIs themselves. When that time comes, and that time will come really soon, guess what is going to be our language of choice? Folks, thank you very much.